Thanks, Peter, and I'm delighted to be here. My name is Kevin O'Donovan, and I get to spend my time looking at new technologies and innovations right across the energy sector. So, for about the next 10, 12 minutes, I want to share with you some of the future energy technologies that I'm keeping an eye on. Now, with the breadth of technologies going right across the energy industry today, from oil and gas to utilities and everything in between, this is a snapshot of the things that I find interesting. Now, my own personal background is I come from the enterprise IT space. So I was with the Compaq, HP, and Intel recently with Intel, where I set up and led our sales into the energy sector worldwide. But when I'm looking at new future technologies, it's not just let's say, the digital side of the house, digitalization. I'm also keeping an eye on some of the things that are happening around chemical innovation, on materials and mechanical. Because if you look at some of the things we'll talk about over the next 10 minutes or so, they're kind of combinations of everything. And we talk about the industrial internet of things, and we talk about new material science for membranes, for in oil and gas or in wind turbines, and. So it's not just one size fits all. It's a combination of the different technologies that come together that'll actually deliver us the energy transition. And the topics I want to cover briefly are energy storage, the future offshore, the carbon capture technologies, digital twin, and blockchain. So let's jump into energy storage. What I find fascinating about energy storage technologies is that they basically encompass all of the four categories prior. It's got everything to do with digitalization, IoT, and. But there's electrical, there's chemical, there's mechanical, and there's material science involved in all the different types. Now, many of you watching will know of energy storage for many years. Some people would say, hey, pumped hydro has been around for donkey's years, lead acid batteries. Today, in the general media, we talk about energy storage. People normally kind of go lithium ion in electric vehicles and some grid storage. But depending on what you're trying to do, whether you're doing fast frequency response in the grid, or whether you're looking for a couple of months or a year's energy storage in a salt cavern, there's different technologies. And this diagram here is from the European Association for the Storage of Energy, EASE. And it gives a great overview, or in my opinion, in terms of when you think energy storage technologies, think there's chemical, there's electrochemical, and that's where the classic batteries, lead acid, lithium ion, and all sorts of other chemical combinations. You also have flow batteries in there, which also have a role to play. We talk about electrical energy storage. So think supercapacitors from the likes of Maxwell and Arrow and folks like that. Totally different use cases, but again, part of the story. You have mechanical, a lot of stuff around compressed air. We have a lot of things around liquid air, cryogenic air, flywheels, plus gravity. There's a bunch of companies out there and across the globe, and they're pulling up concrete blocks up on a basically kind of a crane structure when there's plentiful energy and then releasing it. So when we start thinking energy storage technologies, there's multiple different types of innovation going on, be it in the chemical composition of a battery, be it in terms of electrical properties, be it mechanical engineering. And again, it's just trying to get across that it's not one size fits all. And it depends on where you are in the world. It depends on what you're trying to do. It depends on what auxiliary markets you're playing into. But again, it's a great way of showing that the innovation in the energy transition today isn't all about digital, or it isn't all about lithium, or it isn't all about one thing. It's a combination. Now, the second topic that kind of leads into this is the future offshore. And this is a diagram I got from Catapult on a recent webinar. We're all familiar today with offshore capabilities and oil and gas rigs and pipelines coming into refineries and boats and. Well, imagine the future, and especially here in Western Europe, where we talk a lot about offshore wind, and not just offshore wind that's fixed on the bottom, but floating offshore wind. There's massive plans for floating offshore wind out there in the Atlantic Ocean, off the west coast of Ireland, Norway, you name it. So the idea is that you have massive floating wind farms, all connected together, Potentially, they're connected into an energy hub out at sea. Denmark are building an artificial island to start collecting all of the, if you like, the cables and have the substation. They may transfer it into another, if you like, storage technology. They might turn it into hydrogen, turn it into ammonia on this on that artificial island, and then ship it off somewhere else. Boats, kind of LNG type carriers, or on pipelines. And obviously, if you look at the whole generating hydrogen, maybe you're getting it from natural gas. You want to do things like capture the carbon, use the carbon to put it back down for enhanced oil recovery or gas recovery, and. So what we're looking at again is not one technology, but a whole lot of joined up technologies. And I suppose the key thing for me is that, well, where do you get the technologies for floating wind? Well, if you look at people have been floating oil rigs for many years. Now, I know it's a different scale and the size of a big oil platform versus a floating wind turbine, but some of these wind turbines are like, whatever, 15 megawatts. So they're big machines. So a lot of the technologies from the oil and gas companies, it's the same kind of thing. And if you start getting into hydrogen, hydrogen's a gas. So all of the talk we hear about, well, can we put hydrogen into the natural gas pipelines? Kind of, but there's different corrosive potential. Obviously, this is where you go back into the chemical engineering, the material science. But here in Eastern Europe, there's folks now looking at putting in a blend. Maybe supposing we only put in 15% of hydrogen into a natural gas pipeline and start there, and then you start getting into the whole hydrogen economy. Now, one of the things to get to the hydrogen economy, in my opinion, and for anything in the energy transition, is we need carbon capture. And again, carbon capture for many in the oil and gas industry is not new. We've been doing enhanced oil recovery for many years. But if you look at any energy company out there today, or any industry like the cement, the steel industry, many of them, or I'd say almost every one of them, have pilot projects around carbon capture using all sorts of technologies, whether it's as it's pulled out of the ground, before you combust it, after you combust it, or you pull it out of the air. Direct air capture technologies are a thing. Look at what Climeworks are doing in the US. Climeworks here in Europe, and Carbon Engineering in the US. So that's a thing. And again, if you look at some of the technologies used in carbon capture, huge amount of chemical engineering, material science on new membranes, and digitalization has a role to play. IBM, in a recent announcement in February, we're talking about how they're using their quantum computer to come up with new molecules for membranes, right? So again, it's kind of the joining the dots that, oh, well, we didn't do this before, but who knows what we're going to be able to do tomorrow because of the future technologies and the way they come together. Now, whistle-stop tour of some other digital technology. You'll probably all have heard of a digital twin. And this is not a new concept. And people have been talking about, well, I have an existing refinery, or I have a wind turbine, and I'm putting in all these sensors and I'm getting all the data so I can see what's going on, and I do preventive maintenance and. Well, what people are now doing is they're taking, if you like, the digital twin information from a bunch of devices, and they're actually creating models, simulations, to put them together to say, well, I can actually get all the data from all the devices in a refinery, in a wind farm, in a grid, an electric grid, and actually build out an entire digital twin of the entire facility. Enel in Italy, one of the largest utilities on the planet, they're building a network digital twin. And many of the oil and gas companies and the EPCs and whatever are looking at the entire concept of building out a digital twin model of a refinery, of an oil and gas field, pipelines, you name it. And that's not just for designing it. It's designed in a CAD system. I can do simulations and all this kind of stuff. But then I can get the real-time data as I'm building it, as I'm operating it. So it becomes a kind of a living model. And using that living model, I can also go off and go, what if? What if this breaks? What if that shuts down? So you get a complete simulation. And what other companies are looking at is going, okay, so I'm getting all the sensor data, but look at what we're doing with drones for capturing images. Look at what's going on with low Earth satellites for capturing things like methane emissions. People are walking around with body cameras. There's more augmented reality because people are, trying to see what other people see so you can help them out, because in today's world, you may not get all the right engineer onto the right platform at the right time because you can't travel around. and. So people are taking all these different data sources. So you becomes a living digital twin of an entire infrastructure, and it's almost 3D everything. And that has huge implications on the way we plan, we design, we actually operate. And the whole concept around, let's say, preventive maintenance, being able to do predictive analytics, and obviously the software behind analytics and machine learning and AI and. But you can see where all that's headed, right? It becomes a digital representation of your entire business. That's going to be interesting. Now, the last topic I just want to touch on is blockchain. Now, many of you will have heard of blockchain, and there was a lot of hype around blockchain technologies over the past couple of years. And probably everybody has heard of Bitcoin. Now, Bitcoin is simply a implementation of blockchain technology. Blockchain technology it's like a programming model. It's a distributed ledger technology, and you can do distributed ledgers without using blockchain. But what blockchain allows you to do is create an immutable record. So, unlike the databases we'd have in the sky with all the data, where you can go in and change things afterwards, if something's written onto the blockchain, you can't change it. And what would you use that for? Well, supposing cybersecurity is an issue. So, supposing I want to make sure that when I'm upgrading firmware onto every device in an oil refinery, in a wind farm, in the grid, it writes down a record into the blockchain every time I update a piece of firmware, a piece of software. I can't go back and change it after the fact. I can't go back and redo something. So it's a great way of showing what was done when and can be used for compliance. And as we get more and more into tracking things in the supply chain, and we get more and more into people saying, I want to see for your ESG goals, what are you doing? How are you doing it? Where are the raw materials coming for that wind farm? What's the embedded carbon? Where did the steel come from? And. You're going to start to see a lot more blockchain enabled systems. And what blockchain does as well is that it's distributed. You'll hear people talking about DApps. So it's not the big cloud in the sky, it's distributed around everywhere. And again, it's a paradigm shift. And you'll hear people talking about energy tokens and tokenizing energy and. So again, blockchain is something you're gonna see a lot of that right across the industry, not just purely from financial, but from operations and. Now, that was a whistle stop tour, as I say, of some of the future energy technologies. And I was trying to give you a flavor of the fact that it's not just about digital or mechanical engineering or chemical engineering or material science. It's actually a combination of them all. So you can't do one without the other. And with things like energy storage, carbon capture, hydrogen economy, digital twins, and that's where I see some of the complexity going in the future, but also a lot of the skills that we need. We actually have in the industry today. They're just doing different things. But it's going to be an interesting couple of decades. Anyway, hopefully that was interesting. Thanks.